Hello, everybody. I think the after lunch is the one to have because I have a handful of people here. I appreciate you guys all coming. I'm Anthony George. I own a company based out of Wichita, Kansas that does industrial integration. So we help small and medium manufacturers integrate these technologies that we're talking about into their manufacturing environments. We primarily target small and medium manufacturers, so not companies like Cargill or Coke. They have in-house data scientists, data analysts, industrial cyber people, but we help these small and medium manufacturers, mom and pops as we like to call them sometimes, help them apply this actual technology. This is a link to my website, but what I'm really trying to accomplish here is this is my LinkedIn. I'm trying to grow my LinkedIn. This is all part of what growing a company is about. So, and to get the information out there. My background, scan this will also be at the end if you want to scan this. So I have a degree. I grew up in Rose Hill, Kansas, near Wichita. I joined the Navy right out of high school. When I joined the Navy to actually be a Navy SEAL, but I got hurt and I got reclassified into cryptology. So I ended up after 6 years in the Navy as a cryptologist. Got out of the Navy, went to college to get a degree in computer programming, and then picked up a job working for Raytheon or defense contractors on various projects. At the time, it was high altitude unmanned aircraft. I joined the Kansas Air National Guard at the same time and became a reservist. Over the next few years, I became a cyber warfare operator. So I was attached to a cyber protection team out of Wichita. I was actually the first hire for the cyber protection team in Wichita, and we were tasked with securing some of the nation's most critical assets, primarily around industrial control systems. So I was born out of that. I attended some schools in the Navy for building security systems, but this isn't about me. I'm going on here, but I do hold a CISP and a SANS certificate in forensics, cyber warfare operator, cryptologist, 14 years DoD systems engineering. 3 years ago, I moved back from Italy and I started this company. It was initially a different company and we pivoted a little bit. So I initially started offering industrial cybersecurity services. But what was really needed as I walked these factories is what I understood is that these manufacturers actually needed help with the digital transformation or applying the technologies. So I took some of my systems engineering experience and my industrial cybersecurity experience, and GCE was born or rebranded. This is the long list of, this is what, I don't know, this is, I even wrote this before ChatGPT really was in my life, but we go into existing factories and we modernize and secure them. So we build smart factories, the wrap around them, the building, the HVAC controls, the systems, we bring all those in addition to the machines. And then what we try to do is we try to normalize the data over this entire infrastructure or ecosystem so that we can now use machine learning algorithms and AI to kind of drive decisions around the processes. Um, and such a small group and it's B-sides. If you guys have any questions, just yell them out so I don't get bored standing up here just saying what I always say to people. So any questions, comments, whatever, and we got a small group, so let's hear them. So just to cover how we got here or the way that technology advances here is we have the first industrial revolution or the industrial revolution as it was known. Basically machines were created, cotton gin. Instead of doing it by hand, you had a machine that could do the process. The second industrial revolution really was powered by electricity, but what enabled that now is for multiple machines to be working in conjunction. You hit one button, some machines happen. Assembly line for Ford, most commonly known, mid 1920s ish. The third industrial revolution. This is basically the automating of factories. So you hit a button and the process starts, and many machines are working together. So this particular industrial revolution in the United States was dominated by countries like Germany and Japan because they embraced these technologies. And so at that point, we offshored a lot of our production, decoupling the engineering of the manufacturing processes from the actual process, which left us at a slight disadvantage in producing better products over time. And then we have the fourth industrial revolution. Probably really kicked off around 1999 when TCP/IP won the internet wars and the internet really took off. Before that, there was stuff like NetBIOS and NetBEUI going on. There's some different type stuff, but now we have this common language that we can communicate. And the thing about industrial revolutions is you oftentimes don't know when they start until after they're over. So what we are amongst now is what many believe to be the fifth industrial revolution, which is AI. So I know who here hasn't heard of AI? It's crazy because when I didn't expect anybody because I've heard it like 20 times a day, more. But when I first started giving this talk 4 years ago, most of the hands would go up in the room, and now today it's common knowledge. So this is a presentation that I gave in Wichita 6 months ago, and I submitted it to BSides to get in. But um, things have changed. There's going to be things in here that are different than I gave before. As we learn how to use technology. So first industrial. Oh man, I already covered all this. We're flying through here. Fifth industrial revolution. Fifth. This one fell flat in Wichita. Is this funny to anybody? Does this need to come out? Okay, this is B-sides. It's a lot better. Like I heard people cussing, so I might fucking cuss. I don't know. Oh man, I'm live streaming from my daughter's on here, you guys. So time frames for what happens and what really happens is in the mechanization all the way to the personal. So we're doing people to machines now, and the third is machine to machine. So and then it's machine to human, and now it's going. You're going to get chips in your brain, and it's going to run a robot across the room. Who knows? What I will say is I have no idea for the first time in my life that I can't even really think about 5 years from now what it's going to be like. I was in uh, full disclosure. I spend most of my time in business development now, which is why I love here because this is the technology. I miss being in the technology as much as I was. So this is a great place to be in the technology. But as I go to these businesses and I'm helping them apply this technology to get them through these industrial revolutions, I'm telling people not to buy software, which is crazy to me. There was a certain point where I was like, software runs your business, spend the money on the software. But now you can prompt AI to create the software. So really your competitive advantage is going to be high quality people making good decisions and your data infrastructure, the data lake, the data layer, the back end of the software, the front end of the software from 5 years. I don't know what it's going to look like, you guys. It might just be an AI generated thing, but I can't predict this. And I'm 42. So I grew up in the 80s and I know what Skynet is and I watched Terminator and I did all this stuff, so I've read 1982 so I have a little bit of idea what some people can see into the future, but for the first time in my life, it's a little bit more scary. Thirsty. I speak fast sometimes. So is there any questions at this point? Anybody want to mix this up a little bit? Anybody got an experience? I have a little story. Um, I was reading a story about a deep fake. So this is something that I wouldn't have spoken about even 6 months ago. Or something really interesting in this is if you watch a video of Will Smith eating spaghetti. This is kind of the famous one. If you've seen it, the original one is terrible, but it's like, oh, that's cool. That's cool. When I first saw it, I said, that's neat. When you see it now, it's like, is that actually Will Smith eating spaghetti? I don't know. So what happened, the recent story was $25 million deep fake. CFO of a company calls an employee voice communicates with them, and the deep fake convinces the person to wire $25 million. So this is a whole different attack vector than we've ever seen before. But gone are the days when you tell grandma, man, look at the words. They're not even spelled right. No, you don't have to speak English to write well-crafted phishing emails now. So you can't even tell people do what. Yeah, video, face to face. They were face to face. They thought they were doing the proper protocols to do that, but you can't even trust that anymore. Man, someday, guys, we won't be able to trust the person standing right in front of us. But that's a problem for my kids, hopefully. So, so retired from the military, cyber warfare operator, and just to cover what I think is so dangerous about this particular technology is normalizing it as a weapon. So just like we did with nuclear, we normalized submarines, attacking ships that were defenseless with stuff under the sea. That wasn't real humane at the time, but we're going to start using this, and it's being used. It's already being used. I gave you guys an example there, but you can craft really good malware with AI. You know, I'm telling you that it's creating malware. Write me embedded code. Oh, I'm not supposed to move off of this. Oh, have I seen? I've seen China fighting the robot dog with the drone in the air. You know, and I've spent. So I was a project manager for WSU Tech's Smart Manufacturing Incentive. So we had one of those dogs, and it's Boston Dynamics dog, but you can buy cheaper uh, Temu versions or whatever from China. Well, it might not be cheaper now. I don't know, but that's a political. That's not. That's any too much a political statement for this place. But yeah. So the AI, the robots finding each other. The world's going to change. You know, if you need to shoot a robot, use magnesium shotgun slugs. That's not the topic of the conversation, but that's what I've thought. Because the magnesium will ground all the terminals and stuff and cause it to short circuit. So you want that metal spread out throughout the robot. But what was that? Yeah, that's right. You know, you make a little fire that can't be put out. So what do we do? So I walk into a factory and I help these manufacturers get to the other side of this industrial revolution. So the first thing that we're going to do is digitize the information. This is where IoT comes in. This is where you start to pull all the data points that sit in your environment. You're trying to get them out of that environment into something. Because I literally will see a piece of paper that will say I made 1,500 parts, and they'll write it down at the end of their shift. They get to write down the number they want to write down, and they might get paid based on the number that they write. And they hand it to the shift supervisor, and then that shift supervisor reads it, but it looks like it's 500 parts. And now it gets put into the ERP or the software that runs the organization as 500 parts, inventory's off, or it smudges, or it's in the wrong language, or it's just not passed right. So how do we ensure that the data is accurate? And this is where IoT comes in. And Isaiah is not in the room, I don't think, but Isaiah, yeah, Isaiah gave a good talk on how to attack these IoT devices upstairs, and he's absolutely right. That would play into how you could essentially data poison your models. So we walk through, we look at the environment. You know, I I speak a lot about manufacturing because that's what I work in. I do have some knowledge in oil and gas and power generation, petrochemical stuff, but I'm gonna stick mostly to manufacturing here. So we install the sensors. So you got a machine that's been sitting there that's been running for years. Maybe was installed in some cases in the 1960s, but it's a machine press that comes down and press. Does anybody here work in manufacturing? Handful? Yeah, I know you do. This is the industrial cybersecurity guy to know right here. It's Joe. I won't say too much. I don't know what I'm supposed to say about him here, but so we walk in, we try to get the data out of the machines. The machine maybe is there, it's still making products, but we want to know what's coming out. We can use cameras, we can use IoT sensors, we can use a PLC, we can run wires, and then put sensors all over the device, but we can figure out what the machine is doing, and then over time we can make some predictive analytics. Maybe it's around machine maintenance, maybe it's around scheduling of your plant. Then we set up industrial software infrastructure. We build the infrastructure. This is the piping. Before I started talking, I actually called my daughter. That's how I kind of get my mind right. She's a biology major at Roanoke College in Virginia, and we talked a little bit of tech, and she was kind of asking about this, what the talk was, and I tried to put it in terms that she could understand, and so it's the nervous system. If you know the human body, it's the nervous system. We're putting in the nervous system, right? What's going to run it? This is the most important piece. Is is setting this up in a way that is not only secure by design, scalable and agile. Because, like I said, we have no idea what's coming. So what we need to have is something that's agile enough to change with the technology around us. And you can't not move. You can't not move. In manufacturing, you're at this point where it's do or die, right? Because a machine shop down the road that pulls their data. So machines make, I work for military aircraft parts producers that supply to like Textron, Boeing, Spirit. That's my target market. Now I do some other stuff. I apply the technology in lower risk environments, and I move it into my higher risk environments once it's secured, certified, and all that stuff. So it's kind of like so I work some in food a little bit. Not like we're taking risk in food or anything. It's just like we won't burn down a plant or something. Um, so we apply the technology, we harden it, then we move it in there. Then we start to pull the data and we look at it. And this is where you can start to use AI, some machine learning algorithms. So the algorithms that we use, oh, I'm sorry, I was explaining a the process of making a part. CNC machine makes a part. It's got, let's say, 5-axis CNC machine, drills holes, cuts, does all that stuff. You extract that data, it's in what's something called G code, machine code. And then that data now can be put in machine learning algorithms that says you can speed up access 6, and that might improve your process 30%, and you might make the parts in 70% of the time with 30% of the material. A machine shop down the road that does not collect the data cannot use the algorithms to do that and cannot remain competitive in this environment. I live in a city that is full of small machine shops that I unfortunately know will go away. Well, I'll walk through the organization and they have captured no data, and I'll go to the next company and they have the data, but they don't know how to use it. Having the data and not knowing how to use it, you're way ahead of the game. Because to train a model, you need data, right? It's all about the data. We should be talking more about data than about AI, because AI is useless without data. So the data structures, the data format, the master data models, how you hold the data integrity across the organization is important. And so we hold the standard, we use an industrial standard in shaping our data so that it's easily understood by AI. Timestamp, what sensor produced the data, and then we put it in a payload or a format that AI can easily understand. And now you're correlating across, I use time series databases because ingestion rate, basically. Ingestion rate, and you don't need relational databases. I'm not trying to get too technical in the room, but clearly I did. Cybersecurity measures, that's why we're here. So what kind of things can you put in place? Zones, conduits, VLANs, subnets, putting some of the standard IT stuff in place and some of the stuff that just you can't do. You wouldn't do it. Training employees, you got new technologies rolling out. You're going to get pushback. You're going to get people that refuse to do it. You're going to get people that say, hey, AI is taking my job. They're not going to want to implement it. But you have to enable them and you have to encourage them to use it. And then you have to tell them how their life is going to be better. You can't just push these products on them and expect users to use them. Compliance and certifications, big in my industry. So it's like, how do you get these things through the process? Aviation manufacturing moves pretty slow in compliance. That's actually one of my big pet peeves. Life sciences moves even slower. So if you're in like pharma or something like that, you'll see this technology probably last. Oil and gas or petrochemical, you apply some weird stuff to a plant and you got a valve that doesn't open and it should open, and you got an issue on your hand. So we all are used to this. I don't have my cell phone on me, but it's right there. But pretend like I'm holding my cell phone. And I used to, when I gave this the first time, I pulled my grandma's flip phone out and showed everybody. If you had to compete against me and you had a flip phone and I had a smartphone and we had to order a pizza, check our bank account, and text somebody, who's going to win? The smartphone, right? But there's literally manufacturers sitting out here with this flip phone. But in addition to that, who's going to win even more between the smartphones? The people that know how to use the smartphone. Kids. My son can pick up a robot controller. He was in robotics in high school, but they ain't working on Fanuc robots or these. He can pick up the controller and intuitively understand that. So long gone are the days where, as a manufacturer, your competitive advantage is access to inexpensive labor. Now it's access to intelligent people who make great decisions. Because what's going to be happening is you're going to be faced with a decision, and just like how Netflix might suggest different outcomes, your suggestions will say, turn the factory here, turn it up here, turn it down here. Because you might turn the machine all the way up and be running it at full blast, and it produces a lot of reject parts. But during COVID, if you produced anything, you made a killing. So you might want to turn it up as long as you can get spare parts for the machine and raw materials. Or you might not want to get bad parts and turn it down and get those efficiencies. But to pull that data out and be able to use that machine data to actually drive these decisions. We've covered this, but why do you want to do it? A lot of these places have their information in silos. They don't have access to them. They don't own their data. So own your data. That's very important in what's coming up, because how are you going to, like, a good example is Ford doesn't own the data. Who does? Tesla. You pull your Tesla in the garage at night, it gets an update over the air, and all of a sudden your car's got 10 more miles of range. So Ford, you pull your car in the night, you open up a piece of mail that comes in that says there's a recall. You take it to the Ford dealership. It sits down there for 2 months. Bosch is the company that owns Ford's data. Might have to do a system update, bring that in. It's just that model is old in manufacturing. Um, this is why we digitize. I'm not going to read this to you, but it's because the data can stay accurate. Whenever you involve a human in the loop, it's going to be inaccurate. These data, humans aren't built for these tasks. These tasks suck. The tasks that AI and robotics is replacing, when we have a term for robotics, and what we call is dirty, dull, daunting, or dangerous. That's what we go after for robotics. This is just automating the processes, right? But also boring. If the job's boring for people doing spreadsheets and stuff like that, we go after those processes too, because you're more likely to make mistakes. People are less likely to take that job. We're freeing people up to do some of the more higher level thinking as human beings. Natural progression of society. 10,000 years ago, every single person in this room would be farming. 1,000 years ago, it was like 1 in 2. Today, 1 in like 600 or something. Combines drive themselves, GPS enabled, smart agriculture, don't water if it's going to rain, planting the right seeds. We're finding efficiencies across every industry, not just manufacturing, ag, healthcare, you name it. More with less, American way. Attack vectors for AI machine learning systems. This is, wow. Okay. Well, anyways, I have a little mistake here. I had AI try to fix my slides this morning, and I went back to my originals. So this wasn't even an AI mistake, it was me. So, supply chain attacks. So I've been talking about this one for a long time, but this one's even more important now. So when you're getting software, you want to know what libraries are using that software. Because what I could do if I was targeting power in the United States, for example, I know that Siemens, I had a lot more to bring in, guys, but I parked so far away I didn't bring the whole tub. Siemens S7, this bad boy runs a lot of the infrastructure for power, right? So if anybody hasn't seen a PLC, this is it. You wire stuff in. I could understand that Siemens builds some of this in C code and where they get that library from. I could go in there, and maybe if it's an open source library or something that I can put in there, I can put something in there so that now I know the logic that's running on the back end of this. So that's supply side attack. So you want to know what libraries are built. My company uses open source software. We do that for security purposes and scalability purposes because we can see all the code. We don't want to see code that we can't see. Also, that's going to give you a competitive advantage because if you have information that's locked behind a paywall, as we call it, AI is not going to be able to get to it or understand it as easily. So if you need AI to help you configure stuff or get access to information of stuff, you want something that doesn't sit behind a paywall. So you want open source stuff. And then this right here I'll cover it's called an e-stop. I have a slide coming up, but it's an e-stop. You hit this button and something shuts down. I had a bigger one planned. It's just got wires and it wires right in that PLC, right? So for one, this is a denial of service if you can get access to this button, right? But the idea is when you hit this button, that the processes are going to safely and reliably shut down. Nothing else matters at that point. You have your friends hanging over a meat grinder and he's dangling. It's like, save me. And you go and hit the e-stop and it's like multi-factor. Oh, my phone. Go get your phone. Okay. No. Yeah. Thumbprint. All that stuff. No, my gloves on. No, you need it to happen, stop no matter what. So that's what's most important. Safety and reliability. That's what's different about these systems versus your traditional IT systems. We need to make sure we have positive, safe control over them. How you guys doing back here? Data poisoning. You're training your models off of the data. So if you can understand the model that Airbus is training their flight data off or whatever, and then you can poison that data and they train with that data, then you've basically injected your attack into the process. So most of the attacks are going to come data side. You could get access to some APIs or something too and push data into via API, but you can repoint AI. If they're using ChatGPT and you want your own instance of ChatGPT that's trained off of your data, and now that company is making decisions off of what they believe is their own data, instead they're using your data, attack vectors. This is why you guys in this room are going to be the most valuable coming up, because you're listening to my talk for one. So, but it's not here is probably going to be unemployed, but it's not. No, I'm kidding. But um, because you guys are going to have to think about these attack vectors. They're not traditional. The world is going to change so much. You know, we have additional phishing. You know, our traditional attack vector was phishing. Now we have deep fakes. Now we have targeted phishing emails. You can use AI in somebody's email inbox and mark something as spam, and they may never get an email from that person again. And AI can like change that kind of stuff. So there's all different ways to try to do this. And that's corporate side. And that's on the corporate side. You could get access to an engineers on the corporate side there, because you can use AI now when emails come in to respond, and there's a whole workflow for that. So attack vector. The complexity of securing critical infrastructure. So we got chemical, commercial buildings. So what's happening more is, as my business is being requested, services being requested, it's buildings more. So the industrial building. So how do you build a smart building? Whereas a few years ago, that wasn't really a consideration. And Wichita is always a lagging industry with technology. Even though we are strong in manufacturing, we still tend to lag the implementation of the technology. Whereas like Germany or Austria or something will do it right away. And then it's our cost of labor essentially that causes that. Energy, healthcare. Okay, the domino effect. So what happens when you lose an industrial control system? So here's a case study of not a cyber event, but power lines were overloaded in Ohio, I believe, during snow and ice storm. Sagged down, touched the trees. That caused the power station to go out, which caused water to go out. So you lose water in all the homes. So now you got no water in the homes. You lose power in all the homes. So you got no power in the homes. You're going to lose health care. So generators didn't start on some hospitals. So you had potential loss of life. You had untreated water being dumped into the thing because there's no power to treat the water, but the water's got to run out somewhere. So you're dumping water, untreated water right into the rivers. This spread into Canada. This affected subway systems in New York City. People couldn't commute to work. And this is just from overloaded power lines. But now you can talk about what could a cyber event actually trigger in a real life situation. And it is a cascading effect. Rail has effects too that you wouldn't believe, that affects water eventually in some way. They're all tied together. I spent most of my military career studying and doing. Challenging environments. Do you guys think I see Windows 95 when I walk into a factory? Yeah. What would you tell them? Somebody tell me what I should tell them. What do you think I should tell them? I'm going to hear this word I need. Air gap. Can't do it. Why? You won't be competitive. You won't be competitive. So you gotta get the data out of the machine, because your competitor's going to do it. Now, not every single case, right? Not every single case. There's going to be cases where I'm like, no air gap, no air gap, air gap. But you got to work with it. You got to work with the tools. The machine was designed and implemented and put in 1995, and this was cutting edge software. It was warranted, and there's no patches available, and you wouldn't want to patch it anyways. Why? What do you think would cause if you patch the system? You're gonna break it. You're gonna break it. I would, so that's the first thing you say. Oh, we need to patch this. No, because then you're gonna risk breaking the system. Then you're gonna be out of warranty. Then the original equipment manufacturer is not gonna cover it. Now you're gonna have a $1.8 million brick sitting on your hand, and you're a small business. You're going to be ruined, right? So how do you get access to the data? What do you do? Now, yeah, you can put thumb drives in there. You can put it behind a firewall. You can design the data structures in the right way, the zones, VLANs, all that stuff. There's ways to get to it. Who's ever heard of this? Sun Microsystems. Yeah, I cut my teeth on Unix, man, back in the old days. So and I still see this in some plants, but military certainly definitely still runs off of this. So So the e-stops, hit the button, it needs to turn off. That's why you're not running these crazy protocols. That's why you're not going to run encrypted protocols on this. You hit that button. Oh, I'm not going to shut down. Why? Because I username, password, lockout. No. Now, once again, plant meltdown. Why? Because you wanted to do multi-factor or whatever case you wanted to do. So during COVID, this was sped up quite quickly, and then we had AI piled on top of that. So during COVID, there was a rush to connect the systems to the internet because your engineers were sitting at home, your employees were sitting at home. So, and as we know with technology, you never go backwards. Once you get a feature or something, you can't walk into a plant and tell the engineer, like, hey man, you can't take that laptop home and work from home. They'll just won't call you back, you know, because they want the technology, they want the tools, they want to move forward. You're there to solve problems. Gone are the days where you sit there as an IT department and you are compliance and regulation only, where you're the no guy. Who knows an IT guy? Who is the IT guy that says no? No, we're all cyber guys, but you need to say yes. How do we do it? How do we do it? That's the challenge we have. Is you need to get them there, and um, and then to compound it, then you add AI, and the complexities are just growing. So there's 600,000 open manufacturing jobs as of last week, and 400,000 open cybersecurity jobs. Marry those two, you guys, and you'll be getting paid for a while. Joe knows. So applies enterprise security principles to OT systems. So there are things you can do. Backups, you know, you want to, what I try to do is establish a gold state for the manufacturing. So if I need to redeploy an entire manufacturing environment, then I can do that from a known state. Gold discs is where I coined that term from. You segment and you monitor. And then how are you going to respond? Sometimes we just tabletop it and even sit at the tabletop and you can say, okay, your ERP's down. What's your plan? Everybody in the room will just look at each other. We have no plan. We can't run without ERP. Okay, well, your ERP's on the internet. What happens when you lose connectivity? Well, we got no plan, you know? So what is the plan to respond? Because if the first time you're having the conversation is during an incident, you're going to be in trouble. Factories, if things are not coming out the back of that factory, they're in trouble, right? You got 200, 400, 800 people standing around, no money being made. IBP, a beef production plant out in Liberal, cyber event, 2 million pounds of spoiled beef on their hands. Now you got a whole environmental deal. What are you going to do with 2 million pounds of beef that's spoiled or whatever they had? They had real issues, right? So how do we mean time to recovery or repair, depending on what industry you come from? This is where manufacturing and IT will overlap in their terminology sometimes, but how quickly can we get you back online? How quickly can we get you back into production? Manufacturing, in manufacturing, the saying production is king. So how are we producing? Because if you don't produce, you don't make money. Um, Covered that. So what can we do with old school stuff? So this is old school stuff that we all know. Network segmentation, that way you're just going to limit the scope of attack. Asset inventory and visibility, this is pretty rare to have this when you walk into a manufacturing facility. They don't know what's there. You got to walk around, you got to look, you got to be on the ground. Passive, active, scanning, there's different ways to do each one of them. Active is a little more risk, a lot more risk because you're actively scanning it and some of these things can't handle an active scan. So passive is a little safer. Taps, span ports, whatever. IDSs for OT, access control and authentication. So who's getting access to the actual physical access? You hit that button, it stops the plan, right? So that could be a denial of service that actually happens in person. So how are you ensuring that only the right people are accessing the stuff? Secure supply chain, threat intelligence, what's going on? You got to stay up to date on things that's moving too quickly. Challenges to specific to OT cybersecurity is these systems are old and they're expensive. You know, the machine press that makes parts is still absolutely rock solid. Built in 1960s, these are some of the highest quality machines that I have on any manufacturing facility. They go in there, they say, oh, we want a smart machine, let's replace it. And my recommendation is don't replace that machine because that thing's made out of cast steel. Like, it's a good machine. You just want to overlay some sensors on it. You can make it smart. You might tear the controls off. So the controls that run it, the electrical controls that run on there, will actually tear the whole thing off and replace it with a modern PLC that can connect right into the internet or the network and all the controls, and leave the actual machine, whether it's an oven or a press, sitting in place, because it's a high quality piece of a product that does what it needs to do. The tooling's already there. So how do we help these manufacturers do that? A lot of my counterparts or competition will just sell the new machine, right? But small, medium manufacturers can't do that. And they're actually in the right position now to be able to quickly take advantage of the technology over these bigger companies that can't maneuver quite as well in the technology because their data is more spread out. The decision-making process is much longer. If I can get access to an owner of a company that cares, we can be making actual impactful decisions and movements immediately or fairly quickly. We deploy from Docker containers and GitHub. We use standard development processes that are modern, so we can basically cut and paste across each manufacturing facility. Already hardened, already done. So when you need to say, I need to connect your stuff into infrastructure, we got the infrastructure already that's built in ways that's easily deployed. How does AI impact? Because it used to be secured through obscurity. Because it's so weird. The protocols were so weird. Modbus and BACnet, HVAC systems run off BACnet or secure BACnet, right? But if you hacked into a system and then you got access to ladder logic or the code that runs on these PLCs, you had to go find an electrician or an electrical engineer that understood what was going on in this process to do that. Now, throw that thing in AI and explain to me these processes. Modify this, re-upload it. So there's no more, you can't rely on the obscurity anymore. It's too easy to automate that. What you can get in OT that you can't get as easily in IT is like signatures or normalization. So this process talking to that process. Now you can't get every one of them. So this is a problem that you'll run into when you start to deploy these IDSs or IPSs, is then all of a sudden this process that's never been seen or learned before starts. Think about emergency plant shutdown. That's never been seen. You never trained on that because you've never had this particular incident happen. But then now you have that happen and it detects it as a cyber event and could shut you down and therefore causing the plant meltdown that we're avoiding. AI assisted attacks, yeah. Okay, I'm facing this firewall. I'm facing a Palo Alto industrial firewall, and I know it's got this vulnerability in it. Write me an attack for that vulnerability on that firewall. 82% success rate on that. 82%, you guys. Layered, right? And even the layered's not going to get you because it's this. You're going to eventually have these automated step-through attacks. I haven't seen it, but it's coming. So there's some physical and logical controls. Physical just means the actual asset, and then the logical controls is how you're doing it in the digital world. IT, OT collaboration. So it's getting IT and OT in the same room. They honestly don't really like each other much. So I'm kind of their gateway. And I do deal with IT organizations that will say no. It is not uncommon. It's actually quite common. But I do come from IT background somewhat before I got into this, and sometimes I'll bring my syspin in the frame and show it to the guy like I know what I'm doing. But they won't let the technology in there. But the OT, the industrial side, they need the technology. They're the ones wanting. They're the engineers that want their problems solved. So how do we get them in the same room? How do we talk? The easiest way that I found to do it is to provide the IT services and then bring the OT services into the company. So work with the IT. And a lot of times it's even getting them on the same language, because what will happen is, this happened to me a couple of years ago now, but when you talk about a firewall failing open, what would you guys think? What would you think a firewall failing open would do? Pass traffic or not pass traffic? Pass traffic, that's what's expected, right? It's failing open, open the door, let everybody in. When an electrical circuit fails open, any electricians? None? I have a little bit of time in there, but when electrical circuit fails open, it does not pass electricity. So when you use that terminology in a group of IT and OT, they're talking about different things. And so now they're arguing, and I have the unique ability I spent some time in electrical, to understand the differences and the similarities between the two and kind of help with that language barrier there. So getting them in the same room, getting on the same page, using the right terminology is the first step. Um, this is my LinkedIn. Like I said, I'm trying to grow this. I get nervous. I speak a little fast, so I'm 8 minutes ahead of time.